All right, in this video I have something a little different. This is a 3D printed 3-inch Cinewhoop that I built. And go ahead and subscribe to the channel because I'm going to be doing a little bit with this. I'm going to hook a LiDAR system to it to get positioning indoors. And I'm also going to be putting a infrared Raspberry Pi camera on it and to see if I can fly it indoors in the dark. So that's what I'll be doing with this in a later video. So I'll go over what I have on this drone. So the top plate here is a carbon fiber PLA. So it should be pretty strong. I thought about getting a CNC machine and just cutting this part out, but we'll see how this does for a little while. And down here I have PCTPE. It's a little stronger than TPU. So I was able to go a little thinner on the ducts and it still provides protection. And let's see, these are all TPU, the camera mounts for my GoPro. And I took the analog system out of my Cinewhoop drone. So I put it into this one, and it is the RunCam camera. And it's a RUSHFPV tank, 800 milliwatt. And the ELRS receivers in here. And I have some EMAX 2204 3000 kV motors. I thought about getting bigger motors, but we'll see how this does. So inside I have a Flywoo GOKU GN 745 40 amp all-in-one flight controller, and this is the version 1.2. So this is going to be a 4S system. I did put a pad down here for landing, so everything kind of worked out. So even when I added this, it just made it a little stronger, and hopefully it can take some bumps. You see I can hit it, and this is not going to break. This bends, so that's why I chose to use this PCTPE. So I put this little piece of TPU here to go over the screws, and it has some ridges in there, so hopefully it'll hold the battery on there pretty good. So that's it. I want to give it a flight. It's got a basic tune on it. It has a Cinewhoop tune, so it doesn't have a lot of power for freestyle. So I'll just get in the air and see how it does. I'm not going to hook a GoPro to it yet. I just want to fly it, see how it handles. It's a little windy out.
Welcome to OpenTX. Throttle warning. Switch warning.
Here's how it looks with the battery on there. So I'll fly it without the goggles so you can see it flying. Drifting to the right, so I definitely got to do some PID tuning. Look at that drift. But it is flying. Go ahead and throw it into acro. So I can control it a little more because it's not worrying about leveling out. Yeah, it's way to the right on the tune. Okay, let's see if I can throw the goggles on and give it a flight with the FPV. It's all over the place. First, I'll go ahead and calibrate the accelerometer before I go forward. Flies a lot better, a lot smoother. Seems to be working pretty good. Bring it down here. It's actually flying really good with this Cinewhoop tune. I grabbed a battery that didn't have much in it. So I'll bring it in after I loop around here. I have one more pass down here. And I'll go ahead and bring it in. And it's 3D printed, so I don't want to do a hard landing. Alright, that's it for this video. Again, I wanted to show you my 3-inch Cinewhoop that I built. And again, I'm using analog because I plan on switching this analog out with an analog Raspberry Pi camera. So that's going to be in a later video, so go ahead and subscribe. And I'm also going to be adding sonar, taking this plate off, making a different plate to put sonar on it, or to put LiDAR on it. And that way I can hopefully have positioning for indoors. I have a little... It's not easy flying indoors, and I figure just like the DJI Avata, which has some kind of positioning, maybe once I help positioning up to this using the LiDAR and a compass, that I can get some kind of position hold when I'm indoors. And it was a low tune. I was using this pretty heavy battery, an 1850 4S battery, but it handled it just fine, and it actually flew really smooth, just as smooth as the other Cinewhoops that I've had, and I did build this one. All right, and the reason why I chose this flight controller, the flight controller itself is about $139, and the reason why I chose this one is because it has plenty of UARTs on there, because to do LiDAR, you need to have compass. So my compass GPS unit, so that I could do GPS, I have 4 mounting holes here that I can add a little platform and do GPS with it, and that requires, I think, 6 connections by itself just for that. And then the LiDAR's extra connections. So most of the flight controllers, especially the ones that I have, the Pavo 30 and the Cineon 30, don't have enough UARTs to do that. And I'm not good with soft serial, wouldn't know how to do it. So I went ahead and bought that flight controller just so I can do that. All right, if you like this video, please be sure to subscribe to the channel. And again, I'll be doing more with this in the next videos. And until then, we'll see you next time. Thanks for watching.